done this question? Okay, so this is homework problems from exercise 8.13. The first one's question 11. Prove that negative 4 plus 8 minus 16 plus 4 times negative 2 to the power of n minus 1 equals 4 bracket negative 2 to the power of n minus 1 bracket over 3 for all n greater than or equal to 1. You can do your step 1, step 2, starting of step 3. So for n equals 1, first term you could just write is negative 4, or you can substitute, you know, if I substitute into the expression, that should give me negative 4, but you can just write negative 4. Look at what you've got. You've got 4 times, actually I'm not getting negative 4.
It's 16 minus dot minus.
Oh, is that last one a plus or minus?
I think the question's wrong. That's what I'm saying. I changed it to a minus.
They wrote the question wrong in the essence.
Yeah.
Uh-huh.
So I did it with minus.
All right, let's just see. To get that first one, if we put a plus there, we're not getting, we're getting negative 2 to the 0, which is 4 times 1, which is 4. So if that's got a plus, we're getting a, yeah. But what about when n is 2? I'm just looking. When n is, no, it's negative 2 to the power of 0. Anything to the power of 0 is 1, whether it be negative or positive. Now, if n is 2, what do we get? 4 times negative 2. You get negative 8. All right, there's a problem with the question. This should be a minus. No. No, if this is a minus, you've got negative 4. Okay, that is meant to be a minus. If we do n is 2, you get negative 4. Negative 2 to the power of 1 is negative 2. Negative 4 times negative 2 is positive 8. So, girls, there's a mistake in question 11. That's meant to be a minus. Okay? So, yeah. So, left-hand side is that. Right-hand side is 4 times negative 2 to the power of 1 minus 1 over 3, which is 4 times negative 2 minus 1 is negative 3 over 3, which is negative 1. No, which is negative 4. Therefore, true for n equals 1. So, girls, there's a mistake in the question for question 11. This nth term has to have a negative in front of it. Okay? All right, let's keep going. Assume true for n equals k. So that is, now in the back, did they have it as I've got it? All right, assume that negative 4 plus 8 minus 16 plus ... minus 4 bracket negative 2 k minus 1, let's just k minus 1, equals 4 negative 2 to the k minus 1 over 3. True for n is k. Now we prove true for n equals k plus 1. That is, we're going to prove that negative 4 plus 8 minus 16 plus, well, not plus, minus, and then it's a plus. Well, it's, oh, no, put a minus. Because it's k plus 1. That's the general term. And when you replace that k with any number, it'll work out whether it's plus or minus. That is the general term. You still keep it as a minus. 4 negative 2 to the k plus 1 minus 1 makes it a k now. Whoa. Let's see. Equals 4 negative 2 to the k plus 1 minus 1 over 3. We'll know soon if it's right or not. Or with the negative, with the minus. Yeah, because, see, this is the general term, right? You know how you've got your general term there? You know how I put, sorry, up here. This is the general term. When I've got n is 1, I get the negative. When I put n is 2, I get the positive. When I put n is 3, I'll get a negative times negative 2 squared. Negative 2 squared is positive 4. 4 times negative 4 gives me the negative. So the general form stays the same. It's the substitution of the values that gives you the positive or negative answer. Okay? So I don't go changing this general form if I'm substituting n is 1, 2 or 3. The general form is still the same. When I substitute n is 1, I get a negative. When I substitute n is 2, I get a positive. See, because when I get an even power here, or an odd power here, that stays negative and your answer becomes positive because the negative 4 times the negative. So whenever n here is odd, my answer, or even, sorry, whenever n's even, I get an odd power here. And when I get an odd power, the negative stays negative here, and the negative times the negative gives me a positive answer. So for n even, I'll get positive answers, all right? But we don't go and change the general form, okay? And that's why I keep it as negative that and negative that, because the k plus 1 sorts out whether it's going to be negative or positive. Okay, so that's what we're trying to prove. So we've got negative 4 plus 8 minus 16 plus negative 4 to the negative times negative 2 to the k minus 1. I really want to write plus, don't I? Minus 4 to the negative 2 to the k plus 1 minus 1 is equal to. What's it equal? What do I replace? I replace all of this. Yeah. Not working. Yeah, not yours, obviously. I replace, sorry everyone, getting the right pink. I replace all of this with my assumption. So that equals, need some room, 4 times negative 2 to the k minus 1 over 3 minus 4 times negative 2, that would just be k. Okay. What are you going to do here, girls? Because, yeah, let's go common denominator. Good idea. So we're going to multiply this one by 3 over 3. 4, negative 2 to the k minus 1 minus 12, negative 2 to the k all over 3. We okay with that? So girls, this one gets multiplied by 3 over 3. That's what we're doing. And the 3 gets multiplied by the 4. Now what are we going to do? I'd be expanding some brackets. 4 lots of negative 2 to the k. What do I write next? Minus 4 minus 12 lots of negative 2 to the k over 3. Collect like terms. You've got 4 lots of negative 2 to the k minus 12 lots of negative 2 to the k, which is minus 8 lots of negative 2 to the k minus 4 over 3. Now we're trying to show that it equals this thing over here. Oh, why don't we take out 4 as a common factor?
Yeah.
Because that's got a 4 at the front, so take out a 4 as a common factor. And what have you got? Negative 2 times negative 2 to the k. See what I'm doing? Why did I take out 4? Because look where I'm trying to go. There's a 4 out the front. And I'll put the 3 down the bottom too. So I'm taking out a 4 as a common factor here and the 3's out. Factorising the numerator, if you take 4 out, 4 times negative 2 is negative 8. You've got negative 2 to the k minus 1. Now, can you see where we're going? We're nearly there. What's negative 2 times negative 2 to the k? Are the bases the same? Yeah, because that's negative 2 to the 1. Bases are the same. What do? Add the indices. So it's 4 times negative 2 to the k plus 1 minus 1 over 3. Okay? Which equals your right-hand side. Well, that's fine. Therefore, you can do your conclusion. Who wants to call out the conclusion? If. You start off if. If it's true, for n equals k. Jinjin, keep going. Then, you don't want to answer me? True for n equals k plus 1. Anyone next? Since it is true for n equals 1, then it is true 4. N equals 1 plus 1, which is 2, 2 plus 1, which is 3, and so on for all n greater than or equal to 1. Okay. Actually, we need to look at some past exercise 8.13, question 18. Prove that the sum of consecutive odd positive integers is divisible by 4. So that means prove that the first one's 1 plus 3 plus 5 plus, I wonder if we write n squared, no, not squared. Oh, I'm thinking. Good idea. Look, they're not going to not leave you an equation, and then if someone can't do the equation, it wipes out 3 marks. That's not right. They will give you an equation to start with. So to prove that the sum of consecutive odd positive integers is divisible by 4, they'll at least give you that is divisible by 4. So we want to prove that that is divisible by 4. Okay, do you want to get started? So prove that that is divisible by 4. Oh, you know what we can do? We can go into the challenge and see if there's any induction ones in there. Okay, so for n is 1, we've got, remember we're proving that this is a summation type. So we have to prove, whoa. Right, I'd say, yeah, it's got to be for n greater than or equal to 2. That won't even work either. Oh, yeah, greater than or equal to 2. How? How's 1 divisible by 4?
No, you go 1 plus 3 plus 5, that's like...
No, but for n is 1, that's, you're just looking at the first. Yeah, but 1 is not divisible by 4, but 1 plus 4 is. Wait a sec. 1 plus 3 is 4, which is divisible by 4.
1 plus 3 plus 5
is 9. That's not. But what about 1 plus 3 plus 5 plus 7?
Yeah, it's divisible.
Right. Wrong thing down here, because they want the sum of consecutive odd positive integers. So they just want the sum of any 2 consecutive odd positive integers. If you look at 1 and 3, that's 4, which is divisible by 4. If you then look at 3 and 5, that adds up to 8, which is divisible by 4. Then you'll look at 5 and 7, which is 12, which is divisible by 4. So they want, the general form will be that k plus 2. What we're trying to prove is to prove that k plus 2 is divisible by 4 for odd positive. So actually it should be n. We're trying to prove that n plus 2 is divisible by 4. That's what the equation should be. Okay, so a misinterpretation there. So prove that n plus 2 is divisible by 4 for odd positive integers. Okay, that's what our question will be, not that. Okay, but good try. All right, so let's start. It helps if you know what you start with. Okay, so do you want to work on that? So prove that n plus 2 is divisible by 4 for odd positive integers. So let's go step 1. For n equals 1, we've got 1 plus 2 is 1 plus 3 equals 4, which is divisible by 4. This is what you'll see, something like this. N plus 2 is divisible by 4. No, it's not. It's just, no, series are different. They're not the divisibility types. It's just those two.
Oh, yeah.
Yeah. So what we're doing is really proving that n squared plus 2n is divisible by 4. No, we're not. I'm wrong. It's 2n plus 2, sorry. Lapse in intelligence, which is divisible by 4. Therefore, true for n equals 1. Step 2, assume true for n equals k. That is, we want to assume that k plus 2 equals 4p. That's right. Where P is an integer. And if you want, we can write this as 2k plus 2 and even as 2k. We'll just see what we need to substitute later, just leave a line. Okay, step 3, we want to prove true for n equals k plus 1. That is, what do we want to prove? Prove that, this is what we've got. We're off screen. You're trying to prove that n plus 2 is divisible by 4. So we're trying to prove that k plus 1 plus k plus 1 plus 2 is divisible by 4. Okay, so we start with that. Equals. Ready?
Wait, why is it k plus 1?
Oh, because we've got n, we're replacing the n here. This is our question. Prove that n plus...
But if it's the next odd integer, isn't it k plus 2?
Thank you. Ooh. Yeah. Yeah, I think so. Yeah. Yes, k plus 2. Thank you. Thank you. Thank you. Prove true for n equals k plus 2 because that is the next odd integer. Is 2 more from the... Sorry, girls. Really, everyone needs a holiday, especially me. Next odd integer. Thank you. Good. Oh, why have I got k? So this is a 2. That's a 2. Yes. So we're replacing the n. Remember, with the odd and the even questions, we don't do n is k plus 1. We do k plus 2 because that gives you the next even or the next odd, depending on what you're starting with. See, we're starting with n is 1, which is the first odd. So the next one will be n is 3. I hope this is... But you know what? I'm not sure. Wait a sec. So we've got that equals k plus 2 plus k plus 4, which happens to be 2k plus 2 plus 4. I'm keeping it like that. You know why? Because I can replace the 2k plus 2 with, which is 4p plus 4, which is, this is using the assumption from step 2, which is 4 bracket p plus 1, which is 4 times q, where q equals p plus 1, which is an integer. Okay, all good. And conclusion. Jeez. All good. You can do your conclusion. But can you not do 1 plus 1 is 2? You've got to do 1 plus 2. So, therefore, yeah, if true for n equals k, then it is also true. I don't know if I made a mistake on that other even one then. Also true for n equals k plus 2. So you need to go back. Since it is true for n equals 1, then it is also true for n equals 1 plus 2, which is 3. I think I did make a mistake on that other one. I don't remember me ever doing this. When I did the even one before, last lesson, that video, 3 plus 2 is 5, etc. And so on for all positive, odd integers n greater than or equal to 1. I don't know if I did that correctly. I don't remember even thinking that. It was the divisibility one at the end of the further series, the Tuesday. It was the one before this one, 17 or something, or 19. I don't know if my conclusion's right.
Yeah, 17. And
Oh,
outside.
yeah, it is right.
I did put 2.
I'm pretty sure. You did 2 plus 2 plus 4 and so on for all positive even.
5, exercise. Oh, had you watched the video? Yesterday's? No, you were here. Question 25, exercise 8.13. Do you want to have a go? Oh, pause. Please just fix the question. It's 5 to the n is greater than or equal to 3 to the n plus 2 to the n. For n is 1. Just straightforward. 5 is greater than or equal to 5. That's true. For n equals 1. Then you can assume true for n is k, etc. To assume true for n is k, that is, you're assuming that 5 to the power of k is greater than or equal to 3 to the power of k plus 2 to the k. Prove true for n equals k plus 1. You have to prove that 5 to the power of k plus 1 is greater than or, well, greater than or equal to 3 to the power of k plus 1 plus 2 to the power of k plus 1. Okay, start with your left-hand side. So you've got 5 to the power of k plus 1. Now, equals. No greater than yet, greater than where it's greater than. So we're starting with the left-hand side and we're trying to come up with this expression to show that it's greater than those two added together. 5 to the power of k plus 1 is equal to 5 to the power of k times 5 to the power of 1. Now, because from the assumption 5 to the power of k is greater than 3 to the power of k plus 2 to the power of k, we can't put 5 to the k equals that. We now go greater than or equal to. Now the 5 I'm going to move to the front. 3 to the power of k plus 2 to the power of k. So 5 to the power of k is greater than that. So we put that, yes, this is equal, so we put an equal sign, but that line is greater than this line. Now, if I just want to expand this, I'll say, well, that equals now 5 times 3 to the k plus 5 times 2 to the k. I'm putting an equal from that line to this one because I'm just expanding that. The next line is equal to the line above. But girls, I'm trying to get 3 to the k plus 1 and 2 to the k plus 1. Where did 3 to the k plus 1 come from? 3 to the k times 3 to the 1. So that is greater than or equal to 3 times 3 to the k. Girls, because 5 times 3 to the k, isn't it greater than 3 times 3 to the k? And 5 times 2 to the k is greater than 2 times 2 to the k. Since no. This is one of the ways that you're okay with this row? Are you okay with this row here? Because we're replacing 5 to the k with greater than or equal to 3 to the k plus 2 to the k. Got it? So this is using the assumption in step 2. Remember, you must use the assumption. Okay. Now, then we expand. Now, 5 times 3 to the k is definitely greater than 3 times 3 to the k. And why am I choosing the value 3? So that I can get 3 to the k plus 1. And 5 times 2 to the power of k is greater than 2 times 2 to the power of k. Since 5 times 3 to the k is greater than 3 times 3 to the k, and 5 times 2 to the k is greater than 2 times 2 to the k. And now that is equal to, all right, so that, now I'm putting an equal sign on the next row because what I'm writing here is equal to that. Now, if people are getting confused with why I'm putting greater than or equal, there is another way you can do it. If you don't want to swap between greater than or equal, like all this, see, as long as that, and I've got some greater than signs here on my way down to there, I can now put therefore that's greater than that. Okay? If you look, with the first line, you definitely need, the other way of writing it is like this. You have to say that. And now if you go, then you can go like this. If you want to write greater than or equal to every single time, you just need to write the left-hand side out every single time. And then you're allowed to put greater than or equal to. If you only write out the left-hand side once, you put the greater than when it's greater than, but the equal when you're just manipulating the line above. All right? You put the greater than when this line's, when that's greater than this, but you put the equal when you're manipulating. So if you want to write it every single time, you would go 5. This is the other way of doing it, using the assumption. And then so if you want to put greater than every single time, you just go like this. And then you're allowed to put greater than every time. Get what I'm doing? Since. So if you don't want to, look, in your textbook, they don't write it out every time. They've just got all the greater thans. But that is not correct to say that that's greater than this when it equals that. Do you know what I mean? So since 5 times 3 to the k is greater than 3 times 3 to the k, and 5 times 2 to the k is greater than 2 times 2 to the k.
Do we put greater than or equal to?
Yeah, no, greater than or equal to.
For the since part.
Yep. Yep. Oh, you can, I just put greater than. I just put greater than for the since. Okay. Here, at the end of that one, I'd go, therefore, 5 to the k plus 1 is greater than or equal to 3 to the k plus 1 plus 2 to the k plus 1. I'd just write the conclusion on that type. As long as there is one greater than from there on your passageway down to here, you're allowed to say that that, in conclusion, is greater than this. You okay? I'm only putting equal where you're just changing what it looks like. And then you do your conclusion. Sorry? If you're just changing the way it looks, you can then put an equal. But as long as you've got one greater than, it always means that this is always greater than all of those. Okay? All right, girls. More induction questions in the Test Yourself, question 30. Please look at those. In chapter review. Test Yourself, question 30. There's 3 more induction questions. You can do those. Challenge 8. Whatever's highlighted in challenge 8, that's the type I need to do with you.
Oh my gosh.
Yeah, I need to do that type with you. I'll be doing more. I might do a video with those. I'll see how I feel. That's consumer. We don't do that till the end of next year. But you could do, girls, I want you doing the past HSCs on induction, the Test Yourself induction question 30 in Test Yourself. You could have a go with questions 17 and 18, but you might struggle with 18 in particular. Their induction, anything highlighted in chapter. Yep, and challenge. Make sure you do work over the holidays. Oh no. You two girls. Also, girls, in the holidays, I want you working for a good 3 weeks. So I want you working back from the 6th of January. If you're going on holidays at that time, you're going to have to do some work around there, but I want 3 weeks of work.